So example 3 says if 100 feet of fence is used to enclose a rectangular yard, then the resulting area is given by x times 50 minus x, where x feet is the width of the rectangle and 50 minus x feet is the length. Graph this equation and determine the length and width that give the maximum area. So essentially, we have a rectangular pen here, and we have 100 feet of fence to enclose that area. And we know that the width is x, and we know that the length is 50 minus x. And so we're trying to figure out the dimensions that will give us the largest area. And so it wants us to graph it and determine those dimensions. So one thing that I want you to note here is this is already in factored form. We have x times 50 minus x. And so if we set this equal to 0, it's going to be nice and simpler for us to find the x-intercepts because the zero product principle allows us to set each of these things equal to 0. And so we have x equals 0 and x equals 50. That is what our graph is going to look like with those x-intercepts. Another thing is if we multiply this out, we're going to get 50x minus x squared. And if I rearrange those terms, it's going to be negative x squared plus 50x. Now notice our a value is a negative number, which again means we're going to have a frowny face. So I am just going to sketch the graph. So the y-axis or the vertical axis is the area. And then the horizontal axis is the width of the rectangle in feet. And the area is in square feet. Okay, and I'm really just going to sketch this roughly. So one of our x-intercepts is at 0, 0, and the other one is at 50, 0. So that's, let's say, right here. And I'm just roughly sketching it. Let's say our quadratic function and parabola will look something like that. And our goal is to figure out what width here is going to maximize the area. Now I'm going to let you in on a little secret. I told you before that, remember the vertex, if I drew a vertical line here, is called the axis of symmetry because if I folded it over at that line, it'll be the exact same image. And so if this value here is 0 and this is 50, our vertex is going to lie exactly halfway between the two x-intercepts. And so without doing a whole bunch of math, the number that's exactly between 0 and 50 is the number 25. And so the x-coordinate for our vertex is 25. And then we could plug in, if we wanted to, the area when the width is 25. So that would be 25 times 50 minus 25, which is 25 times 25, which is 625 square feet. So that is the maximum area that we will get out of this pen, or rectangular pen or yard or whatever. And so we've already graphed it, and it says determine the dimensions that will give the maximum area. So we already know that x is equal to the width. So then the width is 25 feet, and the length is 50 minus whatever the width is. And in this case, the length and the width will be the same. So it's the 25 feet for the length as well. So these are the dimensions that will give the maximum area. Okay, let's move on. Example 4 says Mr. Kwan is leaving Red Lobster having some of their delicious Cheddar Bay biscuits. He even has a to-go box of some of them. As he is leaving the restaurant, Mr. Kwan sees a politician that Mr. Kwan does not like in the parking lot. One look of his face makes Mr. Kwan throw his entire to-go box of Cheddar Bay biscuits at him. The height and feet of the biscuits after t seconds can be modeled by the function h of t given there. What is the initial height of the biscuits? So we know that t represents the amount of time in seconds, and so we would like to evaluate our function when t is equal to 0. So we're plugging in 0 everywhere we see a t, and if we simplify that, the zeros make a lot of this stuff kind of cancel out or disappear, and we are left with 6. What that means is that the initial height of the biscuits is 6 feet. B says, find the maximum height of the biscuits and the time it takes to reach the maximum height. So if we thought about this in terms of a graph, let's say the biscuits start at a height of there. So the vertical axis is the height, and the horizontal axis is the time in seconds. So it's going to go something like that. And our goal is to try to find the vertex. So we're going to do that by using the vertex formula. The x-coordinate of the vertex will be negative b over 2a. And so that is equal to, here are a values negative 2, our b values 12, and our c values 6. So we have negative 12 divided by 2 times a, which is negative 2. And if we simplify that, that comes out to 3. That means that the maximum height will be attained after 3 seconds. Now what we want to do is we want to take that value and plug it into our function. So then we would have negative 2 times 3 squared plus 12 times 3 plus 6. Okay, so that is in feet, and so we could say that the biscuits will reach a max height of 24 feet after 3 seconds. And part C says, how long does it take for the biscuits to hit the ground? So if we go back to this picture here, for part C, we would essentially want to be solving for the x-intercept or the root, and that will tell us how long it takes to hit the ground. And we want to use the quadratic formula. So let's remind ourselves of the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. And if we replace some of those values, let's remind ourselves a is negative 2, b is 12, and c is 6. So we have negative 12 plus or minus the square root of b squared minus 4 times a, which is negative 2, times c, which is 6, all over 2 times negative 2. All right, so let's go about simplifying that. So we get negative 12 plus or minus the square root of 144. Let's see. Negative 4 times negative 2 is positive 8, and then 8 times 6 is 48. Okay, so if it wanted exact answers, then we would maybe go one more step and think about which one was going to give us a positive answer, because the reason that there are two answers is because if we went in the other direction, there would be a root here and a root at the green ordered pair as well. But in the context of this problem, it only makes sense to use the positive value. And so between the two, the one that's going to be positive is negative 12 minus the square root of 192 over negative 4, because both the numerator and the denominator will be negative, and so whatever that simplifies to, that will become a positive number. Now, if it wants the exact answer, you would leave your answer like that, but if it wants it estimated, then you could throw that into your calculator, and that will be approximately 6.464. And so if we want to write a statement there, we could say the biscuits will hit the ground after about 6.464 seconds.